Recently in the news, I've been hearing a lot about the so-called fertility crisis. Humans are having fewer and fewer babies. There are people like Elon Musk who seem to be kind of in panic mode about this. He thinks people need to start having more babies, and they need to start having more babies right now. This is in direct conflict with what I learned growing up. When I was in high school, we were taught that the human population exploded after World War II, and that we were exploiting natural resources at an alarming rate, an unsustainable rate. My goal today is to look at this from the perspective of a biologist. Is the fertility crisis real? And should we be worried? According to the CDC, U.S. birth rates have fallen 22% since 2007. Similar drops are being reported in Japan, South Korea, Europe. Something seems to be happening, but why? Fox News is on the case. They suspect that women are picking Netflix over marriage. In their defense, here is the CDC data on birth rates. This decline started in 2007, which does happen to be the year that Netflix started streaming. Pope Francis had a different explanation. He blames a lot of this on puppies. People are choosing pets over babies. He says this is selfish and it diminishes us. I'm not going to lie, I do find that argument a little bit silly coming from a childless pope, but dogs really can satisfy our parental urges. Dogs can be thought of as brood parasites. Point taken, Pope Francis. Rest in peace. The BBC reports that nearly 1 million more deaths than births in Japan happened last year. Population declines loom large over Canada, and this is actually causing problems in some cases. And according to the Merrick's website, giving birth is now a national duty in China. Beijing's struggling to reverse demographic decline. And for me to see all of the drama about this on social media and in the news, it's been kind of interesting because I grew up seeing charts like this. This is the human population over time, and as you can see, the human population is absolutely exploding. This chart only goes to the year 2000, which is when I was in high school, when I was learning about this stuff to begin with. Today, the explosion is slowing down, but it is definitely still going if you look at the World Population Clock, which the real-time version is just based on estimates, but they are our best estimates. Over there, you can see that on average, even right now during this supposed population crisis, the human population is increasing every day by roughly 200,000 souls. Just to put that in perspective, there are only about 50,000 Asian elephant souls total. Look at that happy girl. There should be more of them. We're at over 8 billion people right now. Some projections show we will peak in the year 2086-ish with 10.4 billion, and then we will gradually start decreasing. That decrease is why people are worried. If you look at a plague of mice, for example, those that are born as the population is climbing live awesome lives. Those that are alive when the population is declining, not so much. Zooming out again for a brief history lesson will give us a nice little overview of this situation. Early numbers here, of course, are estimates, based on the mainstream understanding of archaeology. Way back here at about 8000 BC is the start of the agricultural revolution. Actually, I'm not sure why this starts at 8000 BC. Most historians put the revolution at 10,000 BC. Before that, human populations were very, very small. There were hardly any humans alive. For hundreds of thousands of years, there was just tiny bands of people. But around the year 8000 BC, people started farming, and human population started to increase. The plague set us back a little bit, but also during that time, Europeans and Asians got really good at farming. They started doing crop rotation and other things that just dramatically boosted the amount of crops that we could produce. This is called the Second Agricultural Revolution. This is also the time where Native American crops really started making it all around the world. Asians and Europeans finally started mastering the growth of potatoes and corn, peppers, squash, and tomatoes. In the 1700s is when a lot of people say it really started to take off, and that allowed our population to just explode. Then, after World War II, we started producing synthetic nitrogen, this fertilizer for crops, and we had a second explosion. We were able to support huge amounts of people. Well, since about the 1950s, this explosion has been trending downward. This shows fertility rates by nation, by continent, not nation. Africa is not a country. You can see that Africa used to have very high fertility rates, so this is children per woman. They used to have, over 6 children per woman back in the 1950s. In North America, we had over 3 children per woman. If you have at least 2, actually 2.1 is the estimate that people put. If you have 2.1 children per woman, what that is, that's replacement. So that's just enough to replace humanity every generation. That makes sense, of course, because if she chooses that replacement is her goal, she needs to replace herself and her male partner. And then the 0.1 is to compensate for, infant mortality, lopsidedness in male-female ratios, stuff like that. Or at least that's the replacement number in wealthy nations. When a war is happening, the replacement number is higher, of course. And then if you have high infant mortality, that number can be higher. But in Europe and in North America, 2.1 is the replacement number. Well, ever since the 70s, North America has been hovering at the 2 mark. And recently we've taken a dip down below 2. Europe has been down for quite some time. And everybody is trending downward. I should point out that for the most part, the reason that we have low fertility in developed nations is not because we have some sort of a physical disability. We're not poisoning ourselves. We're not poisoning ourselves too much. Our sex organs still work just fine. It's that people are deciding, for whatever reason, not to have children. As a biologist, do I think that we should panic? That's one of the questions we're going to be talking about today. The other question is, why is this happening? Even if you're happy that the population is projected to eventually start shrinking, it's not shrinking yet, but it's projected to shrink, that might mean that we can do something for the environment. It still does seem strange, right? If evolution is true, shouldn't organisms always be trying to maximize at least their own number of offspring? Why would an organism forged in the struggle for existence just one day decide, it's kind of a boring game, I'll do something else? Biologically, what the heck is going on here? Evolution does, of course, predict that individuals every once in a while will just decide not to play the game any longer. That's part of descent with modification. Evolution doesn't work without mutation and diversity. But for an entire species to start aiming downward all at once, apparently by choice, that does seem weird at first glance. Most nations, in fact, are below replacement already. Africa as a continent is only barely slowing down, but they are slowing down as well. On Twitter, people are worried that we might be headed towards a mass extinction, and Elon Musk is chiming in there. 35 million views here with this tweet where he echoes that concern. Not the mass extinction of the species, like other people are saying, but he's worried that this might be the mass extinction of entire nations. The first question worth asking a biology teacher, even an internet biology teacher like myself, is, could this actually cause human extinction? And to that, the answer is no. It's very unlikely that we are going to just Netflix and chill until we die, right? But the worry that a lot of people have here is that somehow modern society has become an ecological trap. This is a grasshopper. She's currently caught in an ecological trap. She thinks that this asphalt is loose gravel, and she's trying to dig in that gravel, and she's trying to lay eggs in that gravel. She's confused. Humans invented asphalt. She's not used to that. And so it's triggering her instincts in a maladaptive way. An ecological trap is when a new or uncommon environmental condition leads an organism to perform a maladaptive behavior. When Fox News complains about Netflix, when the Pope complains about puppies, what they are saying is that we have built for ourselves ecological traps. We are falling for those ecological traps, and this could be very, very bad for us as a species. Fox News chose Netflix as their thing to point at, but they're kind of using that as like a euphemism for all the stuff distracting people from having families. But one reason not to be worried about that is that Netflix is not a problem for all of us. Here's a bunch of Amish people doing one of their classic barn raisings. It turns out that the Amish, especially the old order of Amish, are incredibly fertile. Different reports give conflicting numbers, but every source I found had somewhere between 6 and 10 children per female. Ultra-Orthodox Jews, they're having 6.6 children. In Africa, the continent in general, they average 4.1 children. And then Mormons, they're averaging 3.4. So humans aren't going to go extinct. The future is Amish. Survival of the fittest. There's a really fun article over on Medium where Demographer Lyman Stone, who, by the way, he does a lot of really technical articles on why different groups of people have more babies than others. In this article, he calculated how long it's going to take for Amish to take over the United States. They're at 400,000 right now. If you assume that the U.S. population will stay stable and that the Amish growth rate will stay stable, which it won't, obviously, and the author points that out. But if you assume those things, all Americans will be Amish. And thanks to the magic of exponential growth, it will happen far sooner than you might expect. One thing that you notice in these numbers here is that it seems that people who are very religious, deeply religious, have more children than people who are more secular. Why? Why is that happening? And then also, why is Africa in there amongst these, religious groups that some people consider to be a little bit Mormon-y, for lack of a better term? How could it be that the entire continent of Africa is out-Mormoning the Mormons? Sociologists tell us there are different reasons that different groups have unusually high birth rates. We'll look at some really well-studied reasons here in a moment, but first let's keep talking a little bit longer about this ecological trap possibility. The internet, with all of its crazy distractions with pornography and Netflix and social media and all these things, it really might be having an effect on us. And this is especially interesting to think about when you look at this map right here of internet coverage. This is the share of the population using the internet in 2023. Notice that the red-colored countries in Africa on this map, those are the parts with the highest children per female. Those correlate almost perfectly with the lightest spots on this map, the regions of the world that don't use the internet. Again, this is just a correlation. It is not causation, but it's an interesting correlation. I don't know much about Orthodox Jews, but I do know that Amish people also do not use the internet. They don't use it by choice. It's a religious issue. In some of these countries in Africa, people aren't using the internet because they just literally don't have access to it. The danger of putting too much weight on this correlation is that, people who don't have internet also don't have good access to healthcare, typically. There's a bunch of other things that could make this correlation look like causation when it's not causation. What lessons can we glean from biology? Organisms don't just evolve to have as many offspring as possible. Organisms have evolved to detect local cues, telling them whether or not reproducing right now will be safe and successful. This happens in lots of different ways. Storks do this the brutal way. They have lots of babies, and if they can't feed them all, they start killing them. The runts of the litter go first. When times are tough, the European badger will form colonies. Everyone supports the children of the alpha female, and if they don't, she fights them until they do. Even bacteria, even though they don't have brains, they can detect cues in their environment, triggering them either to reproduce or to wait until times are better. This is bacteria making a biofilm. We're looking at millions of individuals right here. Notice that even though these are all clones of each other, they're reproducing by splitting in two. Notice that individuals on the outside of the colony, they reproduce much faster than individuals on the inside of the colony. Those on the outskirts of civilization, they reproduce so fast compared to the inside that they actually smash things and bunch things together. They're pushing the inner city tighter and tighter and tighter. Reproduction happens slower in the middle because it's hard for nutrients to flow from the outside all the way into the center. A very similar thing, it's an analogy, but a similar thing happens with humans. I know this sounds weird at first because wealth is associated with cities, poverty is associated with subsistence farmers, but sociologists have realized that hunter-gatherers and subsistence farmers have far more children than city people because on a subsistence farm, children quickly become a benefit, not a cost. In the Amish religion, farming and other types of manual labor are highly valued. They're highly respected in those communities. In the Amish groups with the highest fertility, they are subsistence farmers. That's what most of them do for a living. Their children start working as young as 6 years old, and they start working full-time, producing huge surpluses for their family, sometimes as early as age 13. This is not unique to the Amish. There are completely unrelated groups in Mexico, people that have been doing subsistence farming since before Spanish colonization, and these native groups farming corn and squash, they also benefit from having extremely large families. Children are their retirement program. If you try to raise your kids in Montreal, they're not going to help you pay the bills until after college. They are just going to drain your bank account for at least 20-something years. And instead of being your retirement plan, they'll probably still come bug you asking for money when you are in retirement. That's how things are in modern life. Bacteria in the center of a biofilm grow slowly because it takes them a longer time to extract nutrients from their surroundings. People living in cities reproduce slower because it takes so much time for them to learn the skills required to extract a living from a city. A 6-year-old can do farm work, but you need years of training to become an electrician. Animals did not evolve to care about the survival of the species. They evolved to follow incentives in their local environment, along with their instinctual urges to reproduce. Having lots of kids and training them to start working young is adaptive on a farm. Having a few kids and investing a lot in their education is adaptive in a city. This makes perfect Darwinian sense. When city folks are frustrated trying to pay for their first or second child, they're very unlikely to go for that extra 0.1 that's needed to, top things off, especially if they have access to birth control, which helps them cope with their instinctual drive for copulation. This partially explains why Amish have so many children, but what about Mormons? They don't typically do subsistence farming. What about Africans? And what's going on with Orthodox Jews? Well, for Mormons and Jews, the church itself is an incredibly supportive environment for family raising. You can think of the church as a breeding ground and a nursery. Within Mormonism, there's all sorts of activities for children to do. They do all sorts of things as a group, which splits costs. You'll often find Mormons that do free daycare for each other. They take turns watching groups of children. Very similar things happen in Jewish communities. Plus, there's one more very important thing that these three religions share: a resistance to birth control. The more extreme Amish groups and Jewish groups reject birth control in all sorts of forms, whereas Mormons are anti-abortion. In Africa, opinions about birth control vary quite dramatically, but access to birth control in certain regions is very limited. What else is going on in Africa to give them fertility stats that are on par with intense pronatalist religions? Africa's highest birth rates are found in regions that are politically and economically unstable. Generations of war, exploitation by outsiders, and so on can make life unpredictable. People of all nationalities respond to situations like this in the same way, and in fact, we respond in a similar way to all life forms in general. You've probably noticed that organisms that live in really chaotic environments tend to have lots of offspring. A single bullfrog can lay 20,000 eggs at a time, but species in stable environments oftentimes only have one or a few kids at a time and dedicate more resources to each one of them. For some species, this behavior is hardwired in their genes, but in many other species, it's not. It is context dependent. One of my favorite examples of conditional clutch size management is found in the leafhopper species Publilia concava. Notice here that the leafhoppers are being tended to by ants. This is because leafhoppers drink sap, sort of like aphids do, and the ants then drink the leafhoppers' sugary poo. Here's an ant drinking right from the source. It's a juvenile leafhopper there. The juveniles of this species are wild looking. These pictures were taken by my friend Jill Arbor. This ant symbiosis he captured here is really amazing to see. This leafhopper species has two different reproductive strategies. Sometimes, and we don't know exactly what cues they use to make this choice, but sometimes they lay lots of eggs, then move to a new location and lay a bunch more, and they just keep on doing that until hundreds have been laid. Other times they lay one small batch and guard them carefully from parasites and egg predators. This little parasitoid wasp down here, she is waiting for the leafhopper to leave so she can lay her eggs inside the leafhopper's eggs. The wasp babies will eat the egg from the inside as they develop. They're sneaky little devils. Both strategies, egg guarding and just laying lots and lots of eggs, both of those strategies work, but it seems that this species will choose to lay fewer eggs and then guard them when they know that ants are near. Ants are not reported protecting the eggs of this species, but once the eggs hatch, they will protect the babies. When leafhoppers are molting, the ants will even act as midwives. Shedding an exoskeleton is a very difficult time in a bug's life. To have assistance like this, that is incredible. Imagine supporting your own police force, military, and medical institution just by feeding the employees your own diarrhea. Again, we're not exactly sure what cues trigger them to lay fewer eggs and then guard those eggs. But under different conditions, the leafhopper lays far more eggs. But in doing so, she doesn't have time to guard them. That's alright though, because eggs in high numbers acts as a type of insurance program. It seems that these little bugs are able to instinctively switch reproductive strategies according to cues they detect in their environment. Humans also switch strategies according to cues we detect in our environments. And while it might not be correct to call this instinctual in our case, sociologists and anthropologists have found that this behavior is nearly universal in every human culture. It doesn't even matter if the people doing it understand why they're doing it. When infant mortality rates are high, people have far more babies to compensate. When infant mortality rates are low, populations lag a bit. People have super large families for 1, maybe 2 or 3 generations. But when we are convinced that the environment is safe, we have fewer offspring and dedicate more resources to each one of those children. This behavior is so universal, it has an official name. It's called the demographic transition. If you go on the CIA website, you'll find a list of countries ordered by highest infant mortality rate. The countries that have the highest number of kids dying per capita. If you look at the top 30 countries here and compare that to our map of high fertility, you find that every single country in that top 30 list is also red on our map, meaning they have very high fertility rates. Women have lots of babies, far more than in the rest of the world. This is not just in Africa. Almost all human populations respond this way to high infant mortality. This is a population pyramid. So down here on the bottom, we see the population size. A larger width indicates a larger population. And going up, we see age. So from newborn to 100 in this one here. On the left, we have male. On the right, we have female. This population pyramid here is very common for what you might find in a hunter-gatherer society. You might also find a very similar population pyramid in a subsistence farming group. You have a lot of newborns. You have really high infant mortality. Kids are dying very young. And there are very few elderly people. For most of human history, this is how people lived. Even though they had very high birth rates, their populations were small because so many people died so young. The carrying capacity of a continent, for example, is way smaller for hunter-gatherers than it is for people who do agriculture. As a group of people starts to form civilization and they start to conquer disease, infant mortality, they move to stage 2. You've got a constant death rate. You still have a very high birth rate. So stage 2 is high birth, declining death. Stage 3 is declining birth and low death. People just naturally do this, and it's almost universal. When infant mortality is low, people stop having as many children. So you get a declining birth rate. Stage 4 is a very low birth rate with a very low death rate. People are mostly dying in old age. Things like war and famine can actually kick people back to earlier stages, and the civilization will actually slowly start to work its way back towards stage 4. And then there is a stage 5 that is not as universal as the other 4. Stage 5 is where once everything is all good and settled, you start to actually have a decline in birth rate. Your birth rate goes below replacement. So here below we have the idealized population pyramids for different stages in the transition. Above we have real countries and their actual population pyramids right now. First we have the US, and then we have Japan. Notice that the United States is starting to get a little bit below replacement here at the bottom. They're a little bit top heavy. I would not call that a crisis, but it does cause problems. Japan's is one that some people do want to call a crisis. It's stressing people out quite a bit in Japan. At least it seems to be. There's lots of articles about it in the news. But also their economy is still growing. They still seem to be doing all right. Here we have India, and then we have Burundi. This one here is very interesting. Remember, we talked about religion, extreme religious groups modifying the way that people have children. Here we have the Gaza Strip. This says 2024 on it. This data comes from the CIA, but in reality, this is a projection from data they actually collected in 2017. This does not actually have accurate data from the current war. Take this all with a grain of salt, but extreme religions can actually distort these population pyramids from the norm quite a bit. but they are fighting an uphill battle. Stage 4 is pretty much where everybody ends up landing. Here we have Sweden and Finland. They're also getting a little bit top-heavy, but not too top-heavy. They're doing all right for themselves. They most closely fit a stage 4 in our idealized version. One of the ways that people deal with a stage 5 decline is they import people from stage 2 or stage 3 nations. Those immigrants will come in and then support the aging population. They'll work in hospitals. They'll find work in elderly care facilities. This can obviously cause some tension. In Japan, there are language barriers. A lot of times immigrants don't speak Japanese very fluently. And this can actually be a major problem in a hospital, right? If you can't communicate easily with your nurse, that actually can become, for you, quite a big crisis. The global birth rate is still above replacement. This graphic was made back in 2023, but today we're still at something around 2.25 children per female. That's the global birth rate. So we're still globally above replacement, but we are trending downward. What that means is that in the future, we could have a stage 5 type decline, and there's not going to be any immigrants to come in and help with the elderly as they're going. How much of a, quote, crisis will that be? That depends on a lot of things. How fast is the decline? If it's really fast, then it could put a lot of people in crisis mode. But it also depends on what types of technology we have available at that time to help economies stabilize and to help the elderly go with dignity and proper care. But it's very important to realize that these are averages. Some women, some lineages, have fertility rates that are far higher than replacement. The future is Amish. People like Elon Musk, though, they are not comforted by the Amish. They say that the mass extinction of entire nations is on its way. Elon believes that AI is the only hope for turning this around. Kunal Shah has a very, very different view of all of this. He recently published what he calls the transient entropic complexity hypothesis. He looks at the global economy as if it were a machine that can be understood thermodynamically. He thinks about human interactions using concepts from physics and economics. What I want to do is go through this little article, not the whole thing, just the main points, and kind of translate this for people into the normal language of biology and psychology, the language that we are more used to when we're talking about human behavior. Starting here in section 2, the Anthropocene as a complexity surge. The industrial era demanded vast networks of human cognition to extract, process, and stabilize chaotic flows of information, mapping the planet, building institutions, codifying knowledge, digitizing reality. The human mind served as the primary entropy processing unit. In evolutionary biology, we talk about niches, or niches, if you're trying to brown nose the French. A niche is the part of an ecosystem that a species inhabits to extract resources. Earthworms have a very specific niche in the soil. They're eating the bacteria that's in the dirt, and they eat all sorts of decaying organic matter. Ospreys have a very specific niche. They hunt shallow swimming fish. Typically what happens when a species enters a niche is they will expand until they reach carrying capacity. Their population will grow and grow and grow until it can't grow anymore. At that point, things are usually fairly stressful for individuals that are alive there. One goes out, one goes in. You can't grow the population larger. Gobies live in shallow seas, and they've pretty much filled their niche. They're at carrying capacity. In the past, competition was so fierce that they started pushing border populations out of the water. Any fish that happened to have traits letting it survive out of water for longer and longer, it could find food out there, it could get away from enemies out there. Those ones were surviving and reproducing more than individuals without land-loving traits, until finally enough of those innovations accumulated until, bam, we have what's called a key evolutionary innovation. They can actually survive and reproduce mostly on land. I mean, they need a little bit of water. They do have to stay wet, but mud skippers are just gobies that now live on the land. They've entered a new niche, and when you enter a new niche, your population explodes again until you reach carrying capacity. Here you can see the math showing a population explosion in my, old college textbook. Humans can do this even faster through key technological innovations. That first big one, again, was farming. We started getting good at that about 10,000 BC. We really got good at it in the 1700s. And then we had the Industrial Revolution. The key innovation, I would say, in the Industrial Revolution wasn't a specific invention. It was mastering the art of mass production. Mass production, division of labor, all of that happened in many other cultures earlier, ancient Egypt, for example. But the Industrial Revolution is where we start doing division of labor at very extreme scales. We go from producing with our families and neighbors everything we use to becoming cogs in a machine. We entered a new niche and we exploded in that niche. A population explosion can never last forever because every niche has a carrying capacity. It's usually invisible. We don't know what the carrying capacity is until a species bumps up against it. There are two typical reactions that a species will have when it bumps against carrying capacity. In this graph, we see that the population went over carrying capacity. They skyrocketed, these little dots here, and then they fell back down to carrying capacity. So you had a population explosion, then a fall. When humans see a different species going through an explosion, we call it a plague. When we witness the fall afterward, like all the mice are cannibalizing each other and there's not enough resources for anybody, we call that a Malthusian collapse. Hopefully that's not what we're doing. What's more common is that the population will just kind of slow down as it reaches carrying capacity. That's because it's harder to survive and reproduce at that point. When you look at these numbers, to me, it looks like we had an explosion and we're starting to slow down. This is totally natural, totally normal. Kunal is describing this very same thing in the language of physics and the language of economics. He's saying the explosion was natural, and he's about to say that the slowdown is natural. So, section 3, automation as the entropic relay. I'm actually going to reword this a little bit here to emphasize something different than he does. With the rise of automation, global digital infrastructure, and now artificial intelligence, the task of ordering information is being transferred to non-biological systems. These systems now handle learning, optimization, and pattern recognition with exponentially lower biological cost. He's writing this with AI on the mind, but we've actually been automating things for a very long time. I think the first big transfer from human labor to automation was the invention of currency, of money. A lot of people, when they're trying to think of an economy, they think about money. But an economy is not money. An economy is just a pile of goods and services produced by a group of people who are sharing those goods and services with each other. That's it. Money is just a new way to track who has been producing goods and services and adding them to the pile, and therefore who gets to take goods and services from the pile. In the past, if you look at hunter-gatherer societies, if you look at small family farms and so on, everything is done without money. People are sharing goods and services with each other based on reputation. And they're tracking that reputation through gossip, through constant interactions, through constant chitter-chatter. You don't want to give stuff to someone who's never going to give back to you. And so you track reputations through socialization. Money is the automatic version of this. When I contribute to the pile of goods and services, I'm given money. And then with that money, I'm allowed to take from the pile of goods and services, and nobody has to know who I am. I can just go to any store, give them the money, and they'll give me a chunk of the pile of goods and services, knowing that most likely, in order to get that money, I have already given to the pile of goods and services somewhere. Of course, there's a bunch of weird ways to hack that system, right? There's a bunch of people who can get money without actually doing anything for it, without contributing anything to the pile, but that's the general idea. That's basically how money works. Corporations are another example of this automation process. We used to have small family farms that produced all of our food. Now we have big corporations, and we kind of kicked out those farmers. Now those ex-farmers have to find some way to contribute to society in a manner that impresses the people who now control the goods that they used to produce before they were replaced by robots and other things. The ex-farmers have to find a way to impress the people that control those resources so those resources will be shared with them again. AI is not so new. We've been replacing ourselves with systems for a very long time now. This is part of why it's so stressful to survive in a city. It's part of why people aren't so eager to keep having more and more babies, because it's very difficult to extract resources out of this complex automatic machine that we've been building since the industrial era and actually before. Kunal predicts, and I agree with him, that artificial intelligence is going to kick this into overdrive. Let's continue reading. Section 4. The population plateau as thermodynamic efficiency. In thermodynamic terms, civilization may be approaching an efficiency phase. The same informational order can be maintained or expanded with fewer human processors. That's kind of dark language. We are processors in the machine. A decline in population might therefore reflect the natural stabilization of the system's entropic requirements, not its decline. And that's kind of a positive view, maybe. I guess it kind of depends on how it all plays out. But he's saying that this decline in population is not necessarily a bad thing. It might just be a natural end to what we've been doing this whole time. Future equilibrium may feature high systemic intelligence with low biological head count. So where Elon Musk is flipping out and saying that this is the end of the world, we need to make more babies, Kunal is saying, hey, look, stage 5, once there are no more immigrants to fill that need, well, that's okay. Technology is there. It can also fill the need. And then maybe the future will be like this. We will stabilize at a small population with tech picking up the slack. This could end up being really nice and utopian, or it could be like, I don't know, we all turn into the Borg or something. Resistance is futile. But the bottom line for me is this. Is the human population going to go extinct because we're not having enough babies? The answer is no. That's not how biology works. Yes, it is true that the average female has fewer children than they used to, but this is not true of all females. Some lineages are growing right now, while others are declining. Whether or not it's going to cause chaos just depends on how fast it happens and how ready we are when it's happening. It's not that Earth having fewer people is a bad thing. It's that suddenly having very few young, fit people could cause a lot of problems. The demographic transition is normal. Stages 1 through 4 are actually just signs of progress. Stage 5, which by the way is not always universal, it doesn't always happen. Some people see it as a catastrophe, others see it as simply a problem that we will end up fixing, because humans are good at fixing problems. In my illustrations here, I'm kind of getting things backwards. So Kunal isn't saying that AI is going to come in the future and save us from this population decline. He's saying that automation, not just AI, but automation in general, as we've gone from subsistence farmers to like corporate animals, automation has been slowly replacing our need, the economy's need, the global interactome's need for humans. Isn't that funny? We built these markets to serve us. Those markets have escaped us, and now we are being replaced by the inventions of that very market. Whoopsies. If you go online and look at how people are responding to Kunal's article, a lot of people are interpreting what he's saying as if it's positive. I'm not totally sure that it really is all that positive. I think what he's saying is that we are replacing ourselves, and we have been replacing ourselves since that early transition from subsistence farming to large-scale markets. And there's really no guarantee that the transition from a large population we have right now to a small, steady population that Kunal is predicting, there's no guarantee that transition is going to be smooth or nice or pleasant to go through. This is the ride that we are riding. Good luck to us all. Maybe Kunal is correct and the future will be super high-tech, lots of AI. Or maybe the future is Amish. Okay, but that's just me kind of doing a joke. But seriously though, what can people do about this if they are worried? There's two very important things. First, build strong local communities. Even if the global economy gets into trouble, you and your neighbors can still do stuff for each other. Number two, a lot of people I'm seeing are very angry about immigration. They think that there's too much immigration. People are worried that it's ruining their culture and so on. There is a solution to this. Hang out with the new kids. Invite them over for dinner. Teach them what's cool about your culture and learn what's cool about theirs. If you live in the US, Thanksgiving is coming up. It's a great time to invite someone over that you haven't yet had dinner with.